Good morning, everyone, and welcome to our webinar, Pandapower meets SENERGY NETS. My name is John Kapetanakis. I'm a Senior Project Officer at Euroheat & Power, and I will be your host for today's webinar. Euroheat & Power is the European association promoting sustainable district heating and cooling, and in SENERGY NETS project is leading the dissemination and communication activities. We're excited to have you join us today as we explore how Pandapower can enhance grid modeling, analysis, and planning, and see what is the application in SENERGY NETS project. Our session will begin with a brief overview of the Panda tools, and then we'll dive into the core of Pandapower, covering the functionalities and advantages. We'll have then a short introduction to SENERGY NETS before we delve into the practical application from our demo site. Finally, we open the floor for your questions and discussion. We encourage you to engage by submitting your questions through the Q&A box and make the most of this opportunity to learn from our experts. During the last part of the discussion, we will have the opportunity to address your questions and, if possible, if time allows, to have a short quiz. Thank you for being here, and let's start it. Let's get started. Before we dive in, I would like to extend a warm welcome to our esteemed speakers. Thank you for joining us today and sharing your expertise. The first one for today will be Odile Capron, who is a research associate at the Department of Sustainable Electrical Energy Systems at the University of Kassel and the Fraunhofer Institute for Energy Economics and Energy System Technology in Germany. She obtained her PhD degree in engineering science from the Vrije Universiteit Brussel in Brussels, Belgium. Odile, the floor is yours.
Okay, thanks a lot, John. I will share my screen now. First of all, thank you, John, for the introduction. My part is related to the introduction to the Panda tools. Basically, the Pandapower, Pandapipes, and Pandapower. So these are three tools developed by jointly Fraunhofer IEE and University of Kassel. So welcome to our webinar about Pandapower today. First of all, here is a table of content. So the topics that will be tackled in this short introduction will be first, the agenda of the webinar series. Secondly, the overview of the Panda tools. Then a short introduction about Pandapower, a short introduction about Pandapipes, and also a short introduction about Pandapower. And to conclude this, a short introduction about the Panda tools, there will be some conclusion. So first of all, yes, here is a recapitulation of the agenda for the webinar series. So as John mentioned, it's a series of webinar, let's say, with our three main tools, so Pandapower, Pandapipes, and Pandapower. So 2 days of the Pandapower webinar. So basically, a great tool to model electrical grids. And for Pandapipes, so it will be in March, so namely on the 26th of March, also from 10 to 11:30 Central European Time. And it's the presentation about our tool to model pipe networks. And for Pandapower, it will be in April, so on the 23rd of April, also from 10 to 11:30 Central European Time. And our tool there is with the focus on flexibility in multi-energy systems. So first of all, so what are these Panda tools? So mainly for Pandapower, we are developing modeling, let's say, environments and tools for electrical grids. So it's an open source software as for the three Panda tools, and it was released in 2017. And so far now in February 2025, so there is 823,000 downloads. So yes, here we should also mention that it's also partly automated downloads. You can find here the link to the GitHub. So since it's an open source, you can also freely, after the webinar, go to this link and check and also download the Pandapower tool. For Panda Pipes, so yes, it's focused on pipe network, the simulation there, and it was also open source released in 2020. And so far there is 66,000 downloads. So here also we added the link to the GitHub where we can really download it. And for Panda Prosumer, so there, as just mentioned, it's a tool that we developed aimed for modeling and analysis of flexibility in multi-energy systems. So it's also the focus of this project SENERGY NETS. And the open source release there is planned for this spring 2025. So it's also the last webinar of this series, and it will be released also at that time, of course. So for Pandapower, so what is Pandapower? So yeah, shortly described, it's an easy to use open source tool for power system modeling, analysis, and optimization with high degree of automation. So yes, I think like Hendrik will show, it's a powerful tool, and also the great advantage we can say is that it's open source, so you can fully use it. The key features, so basically the core functionalities of Pandapower are based on PyPower. So maybe some of you are also familiar with PyPower, and it was gradually modified and expanded. And with Pandapower, so it's possible to conduct power flow calculation, state estimation, topological graph searches, and short circuit calculation. And it's also according to the IEC standard that you can see here. So yes, Pandapower is implemented in the programming language Python. It's also open source programming language, and it allows combining yes, the vast set of Python-based libraries, which is really handy in order to automate workflows for reading and processing input data in different formats, also for proceeding with static and quasi-static calculation, and also for the optimization, and in the end also for processing and visualizing and saving results that were obtained with Pandapower. So the use case, yeah, shortly in the literature, there are already several papers and reference that yes, I just cited some of them, but that are describing the use case of Pandapower, also the capabilities. So it was successfully applied in several grid studies as well for educational purposes. And the calculation results have been validated with the help of commercial software. So here I just mentioned also some of the reference, because there are many actually that are, let's say, highlighting this fact. So that's for Pandapower. For Panda Pipes, or shortly, what is Panda Pipes? It's also a open source PyFlow calculation tool that complements Pandapower in the simulation of multi-energy grids. And for example, it's really convenient for simulation and modeling of district heating and gas systems, among others. So the key features, so basically it utilizes the data analysis library Pandas, and it's closely related to Pandapower, I just mentioned. And PandaPipes, it's also a great advantage, can be used coupled with Pandapower in order to analyze and model multi-energy networks. It was also thoroughly validated and easy to parameterize for fluid models. And yes, the focus is just also what I mentioned previously, it's on pipe network. So where Pandapower focus on electricity grid network, Pandapower focuses on pipe networks. And given, let's say, the console application of PandaPipe, so it's also designed for and suitable for automated evaluation, just like Pandapower. And the open source code, yes, can also allow everyone to freely modify it, so Panda Pipes, and customize it according to their needs. And for the use case, so as you can see on these two pictures, so here below, yes, it can be used for urban water supply and district heating network, and as well gas distribution. And you can see on the left side, so it's district heating grid and a gas grid, and on the right side is the coupling, like just mentioned, between Pandapower and Pandapipes for the modeling simulation of multi-energy networks. And the last tool, so of this Panda Tools webinar series, so it's a Panda Prosumer tool. So what is Panda Prosumer? So it's a tool for consideration of flexibilities in multi-energy distribution grids. So mainly Panda Prosumer is based on Panda Power and Panda Pipes. It makes sense. I just introduced them right now. And also the key features. So actually, we can mention Panda Prosumer enables the generation of static and dynamic time series. So and it also allows to model a wide variety of prosumers and prosumer combination. And also it also includes different control strategies. So this is also highlighted in some publication in the literature. And yes, the use case, as you can also see on the picture, so on the right side of the slide. So it can be used for all household profiles modeling simulation. So for the electricity demand and heating demand, and for the heating and cooling system modeling, and also for coupling of different sectors with prosumer from different energy sectors. So I think it's also quite recurrent, this topic of multi-energy grids and multi-energy sector. So our three tools actually allow to tackle this. And the open source release is planned actually for this spring, so 2025. And yes, just mentioned in the beginning of the webinar, it will be done before the webinar on Panda Prosumer, so before the 23rd of April. Then, as I mentioned in the beginning, the last slide of this short introduction is about the conclusion. So basically, here is kind of a recap of the three different tools and their capabilities or their feature. So for Pandapower, it's one of the first tools we developed for pure power grid calculation. And yes, it was developed based on the introduction of Panda structure and controller for controlling individual elements. For Panda Pipes, it's a standalone tool for pipe network calculation. So it was based on Panda Power. And it's also possible, as we also introduced previously, to couple it with Panda Power in order to conduct multi-energy grid simulation. And it's thanks to the multi-net structure of Panda Pipes. And our last tool, Panda Prosumer, so it's also a standalone tool for prosumer modeling and simulation. And it uses the pandas and controller structure of Pandapower and Pandapipe. So it's like it was introduced, it's a tool based on Pandapower and Pandapipe. So I think this organic one allows us also and you to have a good idea in mind. So a good representation how these tools are developed and what is the dependencies and the interaction between each other. So yes, here it's the slide with the references. So what I mentioned in the slides previously. And for, yes, for concluding this introduction. So yes, now I will give the floor, or I will give the word to John again. And thanks a lot for your attention.
Thank you, Odile, for the overview. I think it's now time to focus on the first Panda tool, Pandapower. Its theoretical basics structure will be presented by our next speaker, Hendrik Maschke, who is a research associate at the Fraunhofer Institute for the Energy Economics and Energy System Technology in Kassel, Germany. He has a master's degree in business administration and engineering, electrical power engineering at the RWTH University in Germany. Hendrik, let us know a bit more about Pandapower. The floor is yours. We can see your slide. We cannot hear you yet.
So now you should be able to hear me.
Yes.
Thank you very much for the nice introduction. I will continue in our webinar today. So as you already heard, we will hear more about Pandapower today. Just a short overview of the contents. So we will talk about, okay, what is actually Pandapower? I think Odile just gave a short introduction also, but we want to know a little bit more about Pandapower. Maybe what are the advantages of Pandapower? Of course, a functionality overview what is the Pandapower framework capable of doing? What are the different network elements? How are they represented in Pandapower? We will speak about the power flow calculation, how to plot in Pandapower, and also talk about time series calculation and also the control module. And of course, we will have a short application example how Pandapower can be used, but I think we will also see some nice examples in context of the SENERGY NET project. So first of all, I want you to get a little bit interactive. So I would ask you to visit this menti.com webpage, enter the code, and or you can just scan the QR code. So just to get to know each other a little bit, to interact with each other. So there are some small questions on what is your background, what is your skill, maybe also in Pandapower. So it would be nice if we can just do that as a first step. So
yes, Hendrik, I'm sorry to interrupt you. The share for the Menti is the link for the Menti is shared already on the chat box for people to join. So you can continue with your slides.
Okay, perfect. Thank you very much.
I just retype it because actually it's not matching with the code here on the slide. So just for clarification, so that it leads to the same Menti.
All right. Maybe you can fix that in the chat box. So I would just like to ask you to go to this Menti. It would be very nice to interact a little bit there. And in the meantime, I can just continue. So what is Pandapower? Maybe in one sentence, it's an easy to use open source tool for power system modeling, analysis, and optimization. And we aim also for a high degree of automation. So that's in one sentence. It was developed in Kassel in Germany, jointly by the University of Kassel and the Fraunhofer IEE, as already mentioned. And maybe to give you a little bit historical context of Pandapower, it was developed in 2017 and originally started as an extension of the existing tool PyPower. And PyPower is like still a part of Pandapower. So it's like the case file to solve the power flow also. And maybe you already heard that. So pandas library, it's also part of the name in Pandapower. So it's a combination of pandas, so the data frame structure, tabular format, and the power flow solver PyPower. And this combined is the tool Pandapower. And it's an independent open source software. So you can you're free to use it. And we also have a nice homepage where you have nice examples. You have getting started guide, you have some tutorials. We also have a nice documentation page where you can read about the different functionalities, especially regarding the electric models and also regarding the code, what kind of parameters need to be put into the specific functions. And of course, we have our GitHub repository where you can see all the source code and check out the latest versions of Pandapower, and of course also clone or download the source code to use it in your own projects. Speaking of that, I want to highlight some advantages of Pandapower. Maybe you can already see here on the right-hand side. So this is the high voltage transmission grid of Germany. So you can see the shape of Germany. This was created with Pandapower. So all the elements are modeled with type data. So yeah, you can give for every specific grid model element, you can give type data, and it's managed in this pandas format. So you have a very simple data management, and each of the elements, for example, buses and lines or transformers, are represented in these tables, and also the results are managed in the tabular format. So on the right-hand side here, for example, you can see the line loading for this small example. So also the results are then yeah, stored in these data frame tables. Then Pandapower is implemented in Python, so this also gives a lot of advantages. So of course you can automate your scripts. You can interact with other Python modules, as we already did it with the pandas library. It's also cross-platform compatible and also enables parallel computing. And this is where we also use it in our everyday business, so to say, to do, for example, large grid studies. Of course, you need a lot of computational effort for that. So it's nice that you also can, for example, put it on a cluster or something like this. And of course, maybe this is one of the most highlighted advantages of Pandapower. Of course, you don't have any license costs because you can just freely use it, and you can also individually adapt the source code. So if you have like a certain feature that might not be implemented right now in Pandapower, of course you can, if you have like the knowledge, you can just adapt the source code and build up your own functions on that. And that's also very nice because of the open source community of Pandapower. A lot of people interact and come together and exchange their knowledge here. A lot of people use Pandapower already, so yeah, bugs can be found very easily. So this is like the thought of open source communities is like maybe one of the strongest advantages here. Speaking of that, we'll come to the functionalities. So first of all, that's also a nice advantage. We have a model library. So you don't need to know specific electrical parameters for all the electrical elements, for example, lines and transformers. So you don't need to know what is the, I don't know, maximum thermal current a line can carry. You don't need to know all the specific parameters for a transformer, for example, tip changer or something like this. So there are specific standard types already given in Pandapower. So you basically, for the lines, only need to define the cross section and a specific material, and then you have specific standard types. And for the transformer, you just need the rating or the power of the transformer. And of course, all our elements are validated also against commercial software. And yeah, we always validate our calculation against other softwares here. Some of our tools here that we can use in Pandapower is, of course, power flow calculation, but also optimal power flow. So if you have the different types of generators in your grid and you want to know the optimal or cost optimal power generation, if you have a different cost for different generators in your grid, state estimation. So if you maybe don't have a lot of measurements in your grid and only have a small part of the grid where you have some specific measurements, you can try to predict or estimate other sections of your grid with state estimation. And also we have a short circuit calculation module, as already mentioned, based on the IEC standard. And maybe also another very nice functionality of Pandapower is topological graph searches. So you can like forget all the electrical parameters in your grid and just do topology analysis. So you can search for island grids, you can search for unsupplied sections, for example. You can see what components are connected to each other. And this is also very important for grid planning and grid operation. As already mentioned, a lot of people already use Pandapower. We have more than 800,000 downloads, and they are partly automated, but we also know that, yeah, a lot of universities and also scientific institutes use the tool Pandapower, and also some grid operators and the German Federal Grid Agency uses Pandapower. To give that a little bit more of a picture, I was talking about all the functions right now, but I want to give it like a more pictorial view. There's also yeah, like a second tool which is based on Pandapower, which offers like, so to say, extra functionalities, which is not part of the open source tool, but it's yeah, important to understand how the whole grid operation or working with Pandapower process works. So first of all, we start here with the grid data. As you might know, a lot of different grid operators have different kinds of formats of their grid data. There are different other tools like Power Factory, Synccal, Neplan, whatever. And of course, first of all, we need to transform this grid data into our data frame structure, into our Pandapower format. And this is a nice thing that also Pandapower offers. So we have some converters that are already open source, but we are continuously developing other converters and trying to put them open source. So that's like the first step, converting some kind of data into a Pandapower grid model, or just create the grid model on your own. And the second big step, this is what also Odile already mentioned, where the tool Panda Prosumer comes in place. So of course you need some kind of scenario data. You need load profiles, you need scenario data, you need some kind of predictions for the future. What is the load consumption in a couple of years? What kind of prosumers will we see in the futures? There will be heat pumps, there will be more electric vehicles, and how will this behave in the future? Of course, you need this kind of scenario data to include that into your grid data, to then investigate some specific aspects in the grid and to do your analysis on that. So we have grid data and scenario data. This serves as an input for Pandapower. Then we have all the different functionalities I already mentioned. So short circuit, our standard type, state estimation plotting in our pandas format. So all the different things and types you can do. And then in the end, with the results, so the calculation results of Pandapower, there are basically three main aspects we are investigating with Pandapower. So first of all, we talk about grid planning. So if you know how your grid behaves in a specific scenario, then you also know what kind of overloadings you have in regard to lines or transformers, for example. So you can think of grid planning. What specific measures, reinforcement or extension do you need to do to have a secure and safe grid in the future, for example? So one big aspect is grid planning with the tool Pandapower. Second one is grid analysis. So if I have like my current grid and I have a specific load or generation situation, how can I analyze my grid in regard to what are the grid losses? How much hosting capacity do I have? So how much, for example, PV generation can I fit into my grid until I see some kind of overloading? And of course, the aspect of reliability and -1 criteria, how safely operated is my grid. And speaking of operation, this is the third column or aspect that you can do with Pandapower, for example, is grid operation. So of course, you can only execute one power flow calculation doing like a worst case analysis, but you can also do time series simulation where you have a bunch of different power flow calculations that occur in a row. And of course, you need time series for that. You need load profiles and generation profiles for that. And then Pandapower is capable of executing that. There, also the controllers are very important. So you can enable also a controlled behavior in regards to the loads or the generators. So let's think of, for example, EV charging stations. You can do smart charging of a specific charging station. I think we will see also a small example on this later on. So, but basically you can control every single element in the grid with a specific controller. However, just to mention that, of course, with the complexity and more controllers, of course, the computational effort raises, of course. So yeah, this gets more complex. The more time steps you have, the more controllers you have in the grid. But just to mention it here, so controlled behavior time series simulation in regard to grid operation is also a very fundamental part here, how we use Pandapower. So let's get to the next page. I already talked about the standard types. So yeah, basically lines and transformers, they have different types of parameters. I mean, they have like, so to say, topological parameters. So at which buses is a specific line connected, at which bus is a transformer connected, where's the exact location, what are the geographical coordinates, for example. But there are also electrical components that are only dependent on a specific type of this element. And here I brought just a small snapshot of the line standard type. So you see, we have like different line types with different materials and also different cross sections. And you can see the capacity, the cross section, the resistance, the maximum current. So all these electrical parameters are already given in our standard type library. So you're just able to use them and don't need to define all the electrical parameters on your own. But of course, there are also functions to define your own standard types if you know like specific parameters of a cable type. And then, of course, you're free to just put them into your Pandapower grid. Just to mention that here, then I want to quickly talk about the power flow I already mentioned. So it comes from the name Pandapower. It's an extension of PyPower. So we have our Pandapower network as an input here. Then this is a power flow calculation is run with the Pandapower run pp function. And internally in that function, a PyPower case file is created. And then you can select from different algorithms how you want to solve the power flow. So the standard one is the Newton-Raphson algorithm, but there are also other alternatives that you can choose here. And then in PyPower, this case file is solved and it's reconverted into Pandapower and into the result structure. And then you have your Pandapower network with the power flow results included. And I mean, this seems like, okay, well, this takes a long time, but it doesn't really take a lot of time. So it's yeah, like milliseconds. Of course, you can run this power flow calculation in Pandapower. Then also, of course, it's very important to plot your grids. We already saw in the beginning one plot. But here I brought another example. This is called MV Oberrhein network. This is also a very nice thing about Pandapower that we also provide some sample networks that you can just use. They are not real grids, but they are very close. At least this one is very close to a real medium voltage grid. And you can see all the different parameters. So in this case, you can see buses. These are just the nodes, of course, the connection lines. And you see the transformer station or external grid connections are the yellow rectangles. And also like a topological search was used here to identify the different feeder areas. So like the red feeder is supplied here by this transformer and the purple one here by this. There's like no connection between the purple and the green feeder. So there's like an open switch between these sections, for example. And we have basically two collections that we use right now in Pandapower. So it's matplotlib and also plotly. You can use both of them, but we are continuously also developing other plotting functionalities. But right now, these are like the core ones that are used in Pandapower. And yeah, I already talked about that. So you can just create collections for every element in the grid and also combine this with topology searches, whatever you want to investigate in your grid. And you can also generate generic coordinates if you don't have any geographical data. So in this case, for this Oberrhein grid, we have actually some geographical coordinates, which is very nice. You will see this later on. But if you don't have any coordinates, you can use Pandapower also to generate a generic graph from that. On the other hand, we also have Plotly. This works very similar to Matplotlib. I just want to maybe highlight some benefits of Plotly. So you can have interactive and individual plots. So you have HTML plots and also can combine them with a Dash application. So you can have like hover information. You can like directly investigate on specific grid elements. You can click on grid elements. So it's to like if you need to really deeply investigate a grid, this is maybe something to choose Plotly in here. If you just want to have a short first overview, maybe then you can use Matplotlib. And speaking of plotting, we also have geo-referenced plotting. So this is the same grid as we saw on the previous slide. So our MV Oberrhein grid, now plotted with geographical coordinates with a map in the background. And this is also very nice in Pandapower that you can just plot grids with geographical coordinates. And you can also use different projections of geographical coordinates, and you can transform between all these projections, like I don't know, Gauss-Krüger zone or whatever projection you have. It's not always that easy to find the correct projection, so you need to play a little bit around here. But in the end, if you find the correct projection, it's very nice to plot your geographical coordinates. And what's also very nice, you can also combine that with load flow calculation results. So you see it's the same grid, it's the same map in the background, but here we have a focus on our power flow calculation results. So we have this color bar here on the right-hand side for the bus voltages and the line loadings. And this is very powerful because you can, at one glance directly analyze and investigate like visually your grid. So let's talk about the line loading in here. You see like a bluish area is a very low line loading, getting to like green, yellow, and red is a very high line loading. So if you look at just the color map here, you see, okay, I don't want to see any red in my grid because otherwise I will maybe face some line overloadings or problems in the grid. But as you can see here, all the lines are blue, maybe cyan here, or maybe getting a little bit green. So we can directly see by just visually analyzing the grid, we're good to go here. This grid is in a good operating status, and we can do the same here for also the bus voltages. So that was a little bit about plotting in Pandapower. I think I have two more topics and then an application example. So we talked already about the time series calculation. It's important to understand here that the time series module is very closely connected to the control module. First of all, we only want to talk about time series calculation. So we just have, so to say, this outer loop here, so just the green one. So basically it's the function run time series, and you can define a specific amount of time steps. So let's say you want to simulate 1 year and you have a 15-minute time step resolution, then you define 35,040 time steps. And of course, you need some kind of data source for a time series simulation. So you need generation and load profiles that you provide into your Pandapower network or like grid model as a data source. And with that in mind, you're good to go to carry out a time series simulation. So you have your start, you define your time steps, you define your data source, so load and generation data. We don't care about the control loop right now. That's for the next slide. Then basically just the power flow calculation is carried out, and it's checked, okay, do we have still time steps left? If yes, we continue, and if not, then we reach the end. So it's basically a normal time series loop for a time series calculation. But it's also important to understand the control loop. So in between the time series simulation, we also have a control loop. If you just want to do a normal time series simulation without any like special controller initialized, no smart charging or voltage controlling elements or anything, you always need a constant controller. And the constant controller is just updating all the power values for the loads and for the generators for every single time step we have. So we always need the control module also to use the time series simulation, to guarantee that our power values are updated in every single time step. But in this control loop, as you can see, first step is initialize all controllers or initialize the control. And here you can also initialize different specific controllers that you want to see or have in your grid. So if we use the example of our smart charging controller again, so you can, for example, also initialize a controller that is only controlling all elements that have the type of EV charging stations, for example, and limit them to a certain amount. You can also give pricing signals to that, for example. So based on different pricing periods, for example, you can have a controlled behavior. So again, you can do a bunch of different controllers here in Pandapower. There are already some controllers implemented. There's, for example, also a battery storage controller. But that's also the nice thing about Pandapower. If you think of any controlling behavior, then you can just implement it in Pandapower yourself. Then, if you initialize your controller, of course, your controller needs to be converged. So, so the behavior or the algorithm that you implemented in your controller needs to be, so to say, achieved or converged. And if this is the case, you finalize the control step, you finalize your power flow calculation, and then you carry out the next time step in your time series simulation. And as you can see, so this big block is quite big. So the more controllers you put into your grid, the more complex controlling behavior you have, the more dependencies between the time steps you have, the more computational effort, of course, you need in your grid here. That's it, I think. So basically you need your constant controller, and it's possible to implement further controllers here in Pandapower. So on this is the last theoretical slide. I just want to give a short application example. So let's look here on the left-hand side. It's a more theoretical example. So we have some kind of grid topology. You have some kind of charging points that might come in the future here. But you don't know where exactly these charging stations will be placed. So it might be here, but in another scenario, it might be in other places. And of course, if you have different years, then you have more charging points or charging stations. This is illustrated in this picture here. So this is beginning from year 2020 to 2040. So depending on the scenario you're investigating, you have a different amount of charging points and also a different allocation of charging points. So let's say we have 3 different scenarios here, the blue, the red, and the green one. And with all these different scenario applications of charging stations, you can run power flow calculations in Pandapower, investigate that. And this will lead to power flow calculation results. And we want to, for example, investigate the transformer utilization. And you can see, of course, with the rising demand due to the electric vehicles charging in the future, we will have a rising transformer utilization. And maybe the system operator has like a threshold of 70%. And we can maybe predict in the future, in the worst case, I mean, we don't know the future, but the worst case that we predicted is maybe in year 2031, we will reach our transformer threshold. So the system operator can already plan for the future. Okay, maybe there needs to be a transformer replacement. What kind of measures do we need to do in the future? And what needs to be done here in the future? And the second one here is regarding the voltages. So here we can see the same thing for the bus voltage. I think it's the minimum bus voltage. So depending on the scenario with a rising load in the grid, we see a voltage drop. And also here we see a threshold for this low voltage grid. And we can also see, okay, the voltage threshold is reached a little bit later, so maybe in year 2035. So yeah, just by analyzing a lot of scenario data, a rise in our charging point allocation, rising load in the grid, we can try to predict what kind of grid planning measures we need to do in the future. So we know we will reach some kind of transformer utilization or get some kind of transformer problems, and we will see voltage problems in the future and can directly see what kind of measures of an extension and reinforcement we need to do in the future here. So I think I've used up my time, so I will come to an end right now. Thank you very much for your attention, and I think we can talk later on in the Q&A session if you have some questions about Pandapower. So thank you very much, and back to you, John.
Thank you, Hendrik, for the deep dive into Pandapower. I will kindly remind to our audience that they can always submit questions through the Q&A box. And at the same time, the questionnaire on Menti is always available through the link that is shared on the chat box. Hendrik, we saw that at the end of your presentation, you shared an application example. And I think it's time now to proceed with another application example, the one at SENERGY NETS. And for this reason, I would like to invite the next speaker, Renato Luise, to give us a short introduction to the project. Renato is a researcher at IFER, the European Institute of Energy Research, and has a background in energy engineering. Is a graduate of Torino Polytechnics and Karlsruhe Institute of Technology. Renato is also the SENERGY NETS project coordinator. So the floor is yours, Renato, to give us a quick overview of what is the project about for those who participate in our webinar for the first time.
Yes, thank you very much, John. I hope you can hear me well and you can see my screen.
Yes.
So perfect. So first of all, welcome everyone, and thank you very much for showing this interest in these Pandas webinars. It's just the first of the 3 series webinars we are gonna hold in the next coming months. So as John said, I'm Renato Luise, energy engineer and project manager, and I am the project coordinator of SENERGY NETS. So first of all, once again, also thank you for Hendrik for introducing us to the Pandapower tool and to show us his main features. I mean, it's really important, the contribution you are giving to the community of modeling, let's say, especially with this open source model. And you mentioned the important numbers. You mentioned, I think, more than 800 downloads. And to be honest, we are really glad to be some of those. Indeed, when I say we, of course, I refer to the consortium of the project SENERGY NETS that I will briefly introduce to you today if you are not yet aware of it. And then Federico will also show us later some application that we had of the Pandapower model in the project. So SENERGY NETS, as you can read here, is the increase the synergy among different energy networks. But what does it mean? What is the target of the project? Our target is, of course, through the modeling and optimization models to optimize the planning of the district heating and cooling and the distribution grids with the multi-energy system models. Pandapower is one of those. And finally, what we want to do is to increase the flexibility and to facilitate the sector coupling for services between the distribution and transmission system operators. How the project is structured? The project is structured in 9 different work packages. You can see on the bottom left a bit more the detail. We will deliver a total of 41 deliverables, achieving 12 different milestones. The project started the 1st September 2022 and has a length of 4 years. The total budget for this project is around 10 million euros, and the consortium is done by 19 different partners, so it's pretty various consortium. Indeed, we include 8 different European countries. The Research Center of EIFER, which is the center for which I work, is the coordinator of the whole consortium. One important point of this project are the demonstration sites. Indeed, we are planning not only to further improve and develop these models, but also to apply in the real world for real case studies those models, and to try to see how, as I said, we are going to optimize, enhancing the flexibility, the whole systems. The 3 demos I'm talking about are finally located in Italy, Slovenia, and France. And additionally to that, we also have 2 case studies in Spain and Sweden, which will not include the physical demonstration site, but still we will develop twin models for replicating what could be optimized in those sites. As I said, here you can see a sort of map of the consortium members. It's pretty spread around Europe, and we're really happy to have a very dishomogeneous, let's say, consortium. Indeed, you can see that we have several research and academic entities, energy supply and services. We also have 2 DSO operators in the consortium and 2 software providers. And on top of that, we also have 3 different associations and networks. Just to show you a bit the demo cases where are located, we have the first demonstrator, which is located in Milan, the second in Ljubljana, and the third in Paris. The additional 2 case studies you can see here, like in the city of Cordoba, Spain, and in the city of Västerås in Sweden. And basically, you can see here in this last table what we aim to develop, the different models. Indeed, of course, you can imagine that every case study has different model that work in a components, that work in a different way at different characteristics. So we are trying to develop the whole models that are included, all the technologies that are included in these case studies. And you can see here basically the five locations that we have and all the different models that we are trying to develop, and that are actually under validation, since I am happy to say that we're in the middle of the project, as I showed you before, but most of the models have been already implemented either in let's say private tool or in open source model, but we are right now at the status of the project going under validation of those models for further implementation on the Panda tools. And since I don't want to take too much time to Federico, that is going to show us how we implemented Pandapower in SENERGY NETS, I would like to thank you for your interest, for your participation. And of course, if you are interested in additional information on the project, please do not hesitate to visit our website, or also to get in touch to me or to John. So thank you again, and John, I let you introduce Federico.
Thank you very much, Renato, for the quick introduction. It's time now to pass on to Federico. Federico Vitti is a data scientist at A2A, based in Milan, in Italy. He has a bachelor degree in mathematics and a master's in statistics. Federico will tell us about the use case of Pandapower in SENERGY NETs. That is the application for flexibility in the DSO market. Federico, could you please share your screen? And
Yes, thank you,
oh,
John, for the introduction. Do you hear me well?
yes, exactly.
Perfect. So just a second.
Of course.
Okay, so
Yes,
can you see
so
my
the
screen?
floor is, yes, the floor is yours, Federico.
Perfect, thank you. Okay, just 1 second more. Okay. So thank you all again for being here today. I'm Federico Vitti, and I work as a data scientist at A2A. And today I'm going to show you our use case. In particular, I'm going to show you how we are using Pandapower for our grid, so for the flexibility in the DSO market. So this is the table of contents. So I would like to make you a brief introduction to A2A. Then we will have an overview about the use case, a focus about our grid, so the demo site. Then I will show you the approach that we are following, some details about the Pandapower network, the electrical load forecasting model that we implemented, and then the first result that we got, and finally the advantages, challenges, and next steps. So A2A is one of the most important multi-utility in Italy, and it likes to be defined as a life company because all its main businesses are related to everyday people life and communities life. As you can see from this slide, the main businesses are energy, environment, and smart infrastructure. So energy, because A2A is present in the entire value chain of energy, from production to sale. Environment, because A2A manage both the urban cleaning, but also the integrated management of waste, in particular in the main cities in the north of Italy, like in Milan. And finally, smart infrastructure. We call it smart infrastructure, and it refers to the distribution of the electricity and gas through the A2A networks. In particular, the use case that we are going to see falls into this last business, the smart infrastructure, because it's related to the distribution of electricity. So let's have a look at the overview of the use case. The main context is the SENERGY NETS European project that have been already introduced by Renato previously. The main goal here is the flexibility of the DSO electrical market. So when we talk about the flexibility, we refer to the possibility to ask to our final user to change their consumption habits in order to avoid possible critical situation of our grid. So if we move to a the specific goal of this use case, so we want to simulate the power flow of the electrical grid in order to monitor and predict the status of the grid, but also to identify any possible critical solution that requires flexibility in the DSO market. So the scope is to deliver an efficient prototype solution that is capable to return an accurate power flow, but then also to provide the output to the flexibility market, and then, of course, get back from it the flexibility solution. The area of analysis, so our demo site is the medium voltage grid located in the east part of Milan, and it's made by one primary station, one substation, 125 secondary stations, 88.78 kilometers of line, and around 28,000 points of delivery. The point of delivery, we can consider them as like our final user. So this is the map of Milan, and this is the grid that we are focusing on. As you can see from the map, it covers a big part in the east of Milan, and it has a route, this orange rectangle in the top, that is the primary station. From it, you can see the red lines that are the transmission lines that bring the electricity to the substation that is located more or less here in the middle of the purple lines. And from the substation, the electricity passed through these purple lines that are called feeder and arrives at the final nodes that are the secondary station. So if we have a look at the electricity journey through the power grid, it arrives at primary station at high voltage, so at 220 kilovolt. In the primary station, there is a high voltage to medium voltage transformer that lowered the electricity from 220 to 23 kilovolt. And then the electricity through the transmission lines arrived at substation. The role of the substation is to pass the electricity to each secondary station that, as I said, are the final nodes of our grid. And this can happen in two different modes, depending on the type of the secondary station we are considering. The first mode is when a secondary station has the same voltage level of the substation, so 23 kilovolt. So they are directly connected to the substation through the feeder, and they don't need any electricity reduction. The second case refers to those secondary stations that have a lower value of voltage, that is 9 kilovolt. So in this case, we need to reduce more the electricity from 23 to 9, and we make it by the use of a medium voltage to medium voltage transformer that is located into the substation, and then it passes the electricity through the feeder to the secondary station. So these are some images about the demo site that we are looking at. So starting from the top left corner, an image of the primary station. In the top right, an example of the primary station transformer from high voltage to medium voltage. In the bottom left, some transmission lines. In this case, these transmission lines are under the ground. And finally, an example of a secondary station, probably the most beautiful one of A2A. So let's talk about the approach that we are following. We can, in our approach, we can identify three main actors: the Pandapower network, the electric load forecasting model, and then the Pandapower power flow. So starting from the Pandapower network, the Pandapower network is how we model our grid into Pandapower objects. So for each element of the grid that I previously mentioned, we create the corresponding element in Pandapower. The electric load forecasting model is how we predict our active and passive loads that that we want to add to the Pandapower network. And we used a previous model that we already implemented in SENERGY NETS. And by using it, we create a prediction for each passive and active loads along a time period, along the time period that we want to analyze. And then we aggregate them at the secondary cabins levels, because as I said before, the secondary cabins are our final node of the network. Then by using the Pandapower network and passing the active and passive loads, we then are able to run the Pandapower power flow through each timestamp of the time period that we are analyzing. And we will see later how. So if we have a look at the Pandapower network, how we model our grid in Pandapower, this is the minimal representation of our grid. It's quite a simple medium voltage grid, and we model the primary station as an external grid plus a bus, just to connect the external grid to the other elements of the grid. And we use the function create external grid in Pandapower and create bus. Then we model the high voltage to medium voltage transformer as a trafo plus a bus. And in this case, we decided to use the create transformer for parameters because we needed some custom values of our transformer. So we couldn't use the standard type library in Pandapower. After the trafo, there's the transmission line. And here we use the create line from parameter as well, because we had some, in our system, we have the specific values for each material of our cables. So we decide to use them to be most as accurate as possible. And on the bottom, you can see the other elements of our grid. And we model the substation, secondary station as buses, of course, with different, with their own voltage value. And the feeder line, we model them like the transmission line, so by using the create line from parameters. These are the results of our Pandapower network that we plot by using Pandapower plotly function. The starting from the top, the yellow square with the orange bus is the external grid. The gray lines are the transmission line. The green bus is the substation. The red lines are feeders. And finally, the blue buses are our secondary station. In this plot, we also use the real coordinates for each elements in the grid. So talking about the electric load forecasting model, we said previously that we have 125 secondary stations in our grid and around 28,000 points of delivery. Most of them are passive users, so users that require electricity from the grid. But we have also 150 active users, so users that provide electricity to the grid. So if we have a look at this image, starting from the right, we are able to retrieve for a specific time period and for each point of delivery, its predicted values, its predicted curves. So if we have a point of delivery that is a passive user, we will have its prediction of its passive loads. Otherwise, if the point of delivery is an active user, we will have the prediction of its active loads. We then aggregate this curve for each point of delivery that stands under the same secondary station in order to have a final aggregated prediction for each secondary station. Of course, if a secondary station has both active and passive user, it will have two different predictions, so the prediction for passive loads and the prediction for active loads. All these aggregated prediction, then we added them to secondary station buses by the use of this function in Pandapower. So we use the function create load for passive loads. Then we use the function create static generator for active loads. And then for using the time series model, we also build the cost control, both for loads and for generators. By using the Pandapower and passing the active and passive loads to it, we then are able to run the Pandapower power flow by using the time series module, so the function time series run time series, that it returns for all the period that we are interested in the results of the power flow. So let's have a look at the first results that we got. This is our results that we got on a specific period in the past that we are testing. In this case, we are looking at November 2024, and this is a report in Power BI, our BI tool that we use for visualizing our results. So starting from the top left, we are evaluating as a measure the power in megawatt for the transmission line with ID N022526 over the period of November. And if we have a look at the chart in the line chart in the bottom, here we are comparing the true measurements that we got from our sensor that are installed on the line versus the predicted by Pandapower, the blue line. Our here we have hourly prediction, and as you can see from the chart, our prediction are quite good. They follow the true values. There is a strange behavior here in the middle of the true measurement, so that it's difficult to to predict, and we are investigating what happened in that period. But in general, if you look at the value of the mean absolute error on the right, that is 0.83, it's a quite good result. We are working to improve it as well. But if you focus on a different period, excluding the strange behavior in the middle, you can see that the mean absolute error decreased to 0.56. So these are the results on the transmission lines. We also want to add the results on the transformers, but also on the feeder lines, so to all elements of our grid, in order to have all the prediction over all the elements of our grid. So the idea here is to predict, to validate our model, and then predict for a month in the future, and then say, okay, if we put a threshold over our power request at maybe, I don't know, 4 or 5 megawatt. If our prediction is over the threshold, then we need to ask to flexibility platform a flexibility solution for that period. This is the macro idea. Okay, let me go to my final slide. So in conclusion, the advantages, challenges, and next step of our use case. Talking about advantages of Pandapower, for sure, as Hendrik said previously, it's really easy to use, especially it's based on pandas. So if you are a Python developer, for sure you are able to use pandas. Nowadays, also Polar is becoming more popular, but maybe, I don't know, in the future there will be a Polar Power, who knows. It's highly specific for grid load analysis. So especially for our case, we were looking for something that was specific for this type of analysis, and Pandapower really fit it. So perfect. And finally, it's complete with utility functions. So it also have many functions that allow you to handle specific situation of your grid. The main challenges that we found in this use case is to retrieve all necessary parameters. This because we needed to create custom elements. I mean, custom value for our elements, like our transformer. So for some parameters, we don't have the real value in our system, so we needed to estimate it or take it from the state of the art. And second, of course, active and passive loads have a great impact on the results. So if you have accurate values for them, you will have a good result in Pandapower. This is the reason why the first of our next step is to fine-tune our forecasting model in order to improve our prediction. Then we will need to process our results and send them to the flexibility market platform, because they require that the result has a specific format for the APIs. So we need to aggregate or, by the way, to transform our results to what the platform requires. And finally, we would like more in the future to scale up our solution to entire and medium voltage grid. This is our long-term activities, let me say. So thank you again. I'm done, and feel free to ask any question. Thank you.
Thank you very much, Federico. Very interesting to see the application at SENERGY NETS. I would like now to ask for all the speakers to turn on the screens so we can have any questions that have been risen. And I will start from you, Renato, as the coordinator. Is there anything you would like to clarify regarding the tool or the application?
What? I don't get the question, John. Sorry.
No, I was just wondering whether you have any questions to ask to the experts or.
Okay, sorry, because I
Yeah.
was reading in the chat if there was some question, and so I was not understanding. No, actually, it's I mean, it's also how to say, really interesting to see the work they are providing, and I'm just really looking forward also for the for the other Panda tool presentation as well. So thank you very much for all the effort and the work you are providing.
Very good. Thank you. Hendrik, would you like to get back to the Menti results? Would you like to comment on the questionnaire?
Maybe if you allow me and we have the time, I can maybe show another short application example.
Oh, yes, of course. Yes. Feel free.
And I will just share my screen again. Okay. Can you see the screen?
Yes, we can see.
Okay, so just to give you like so you can see the minimal example from Pandapower, right?
Mm-hmm.
Yes.
Okay, so just to show you some code as well. So what we are trying to do here, we create a very small minimal example in here. And yeah, first of all, of course, what you need to do. So I used Jupyter Notebook here and I just imported Pandapower. So if you installed it via pip, for example, or you downloaded the source code and put some path dependencies, you can just import Pandapower as a Python library. And then the first part, what we always need to do is create an empty network if we want to create a small network. And this is basically just creating empty data frame structures. And it's giving the whole structure for all the elements and all the results that we create in our Pandapower network. So you don't need to care about any other things in here. You just create like an empty hull, so to say. And then you can fill all the data frames with information regarding the specific elements. So if you call the create bus function, for example, you reference your network object that you just created with the empty data frame structure, and then you just give like the voltage level here and, for example, the bus name. And this is the same way for all other elements. So for example, if you create an external grid, you just need to put other parameters in here. Maybe we can quickly also show the documentation page. So if you want to learn something, for example, about data structure and elements in here, you can click on that. Here, for example, let's click on the bus in here. And here you can directly see the create function. So yeah, here you see what kind of parameters you need to put into this function. And if we hop back into that, yeah, you see what kind of parameters we put in here. So for example, the voltage level. And this is the same way for all other elements. So for example, also for the transformers and the lines, here we need to take care to put like a standard type. So whatever, transformer type. So here we have like a 0.4 megavolt ampere transformer transforming from 20 to 0.4 kilovolt. And we have a specific table type in here. And we can simply access our network object if we just put network object dot the column name. So if we want to access the bus table, for example, in here, we can simply do that. And you can see we get our nice tabular format with all the information that we just put in here where we created our buses. And we do it, for the same way for our lines and transformers, for example, where we also see some electrical parameters that are coming from our standard type. And if we want to run a power flow calculation, we can simply hit Pandapower run pp and put our network object into that. And we can see that we can also access result tables. They are always called just res, so res underscore, and then the element type. So res bus, res line, res trafo, whatever element you want to access here that is calculated. And for example, we can access the voltage levels here in the first column. So the VMPU value is just the voltage at the different buses in here. And for the result lines, we can have a look, for example, here on the right-hand side on the loading percentage. So we see this line is overloaded because we see a loading percentage of 117%. And for the transformer, we can see there's around about 30% of loading percentage. So we just created a very simple grid and run a power flow calculation. And just very quickly to give you some insights, for example, what you could do, we could change the tap position at the transformer. So you can simply access the single entries in a data frame. So for example, for the transformer, the column tap position, we can simply change it to -1. So we change it from 0 to -1. So we lower the position of the tap changer and we run another power flow calculation. And then we see, if we compare that to our previous calculations in here, we see a voltage raise. So let's have a look at bus number 2. We saw 0.96 per unit as a voltage, and now we have 0.99. So due to the position change of the tap changer, we have a different voltage at our buses in here. And the same you can apply for switches, for example. If you create a switch element, there's a flag which is called closed. So if this parameter closed is false, then obviously it's not closed. So it's an open switch. So if we include the switch in our network and we run another power flow calculation, you can see, you get none or not a number results for our bus number 2. Because if you have a look at this small picture in here, we disconnected our switch number, our bus number 2 from the grid. So Pandapower recognized there's an open switch connection and we cannot get any voltage for here because it's disconnected to the grid. And we can also investigate, of course, our load that we put into the grid. And due to the disconnection of the load, we see, it does not feed in any power values. So it's just 0 because it's disconnected from this area. So because of the switch, of the open switch connection. And if we have another look at our result table for the lines in here, we can see, okay, our loading percentage for the line is 0 now also, because we don't have any load in the grid anymore. We disconnected our load, so we don't see any loading at our line that we have in our small grid in here. I think I can skip this topology part. So you can, for example, search for unsupplied buses in here. You can search for paths that connect different components, for example, here. And the last part in here is regarding short circuit analysis. So you can also very simply run a short circuit analysis if you put some parameters. However, if you want to learn more about that, I will just quickly show here in GitHub, on the GitHub page. If you click here on tutorials, You see there's like a bunch of different tutorials in Pandapower. If you want to learn anything about Pandapower, you can simply click through our tutorials in here. For example, here some plotting, Plotly, regarding the standard types. So you're free to just search in the tutorials whatever functionality you're interested in and do the tutorials on your own. So yeah, this was just a small part on Pandapower to show some code, show the GitHub page where you can find tutorials. So maybe just some more input regarding Pandapower. Hopefully I did not use up too much time. So thank you again for the attention.
Thanks again for the additional material, Hendrik. I think we have time for a question that it was submitted by Peter Ostergaard, probably directed to you, Hendrik. It could be something like a clarification. Can Pandapowers auto-generate the network when the GIS data for the different elements are not perfect? For example, when power lines not snap together.
Yeah, that's a good question, actually. Unfortunately, that's not possible. So you'd need to manually adapt the coordinates then. So you need like a good data set, the good data piece of GIS coordinates to properly plot them in Pandapower. And right now there's like no nice function to interpolate, for example, some coordinates of that. The only thing that is possible is if you don't have any coordinates to create like a generic graph from just the network topology, and maybe using that you can try to create the GIS data on your own. But there's like no nice functionality in Pandapower to get rid of like data errors in the GIS coordinates.
Thank you. I don't know if any of the speakers have any questions.
John, I just see the question of an anonymous attendee. I didn't get if the synergy with the district heating is considered in the project, or at least in the case of Myland. Thank you. So my answer is yes, the synergy is considered, but of course, since today we only talked about Pandapower, we were just including the connection of the electric grid. Of course, in the next webinars, when we will talk also about Panda pipe for the district heating and Panda prosumer for the whole image of what we can create, there will be more explanation and showcases. But since you mentioned the case study of Milan, just for your understanding, yes, we are considering the district heating, and you can consider that we have the provision of electricity through the electric grid, of course, and the thermal power. And we consider an electric boiler, a CHP, 2 heat pumps. There is also gas boiler, and of course thermal storages cannot miss. And all this system will be implemented in the models for then supplying heat and power to district heating and cooling according to the demo case.
Thank you. Thank you very much, Renato. I think it's time now to close this session. Thank you all for joining and for your questions. We hope you found this session insightful and get a deeper understanding of how Pandapower can support your grid modeling and planning activities. As it mentioned, the learning doesn't stop here. The webinar is part of a series, and we invite you to join the next 2 episodes, one in Panda Pipes coming on the 26th of March 2025, and the third one, Panda Prosumer, coming on 23rd of April 2025. By scanning the QR code you see, you can access the dedicated page on our website. The slides of this webinar will be sent to all participants, and the recording will be soon released in the YouTube channel of Euroheat Power and shared through the SENERGY NETS website and social media. Once again, a big thank you to all of our great speakers of today and all the participants of the audience. You can find contact information in this last slide. We look forward to seeing you at the next webinar. And until then, take care and wish you a very nice day. Thank you all and goodbye.
Thank you.